Okay, in this video, we're going to learn how to look at the turning points of a graph and how many turning points a graph has, okay? So in this first example here, it says to find the number of turning points, and a turning point is where it goes from maybe going down and it starts going up, or it's going up and it starts going down. For instance, here, this one is going down and then it starts going back up. So that's considered a turning point, okay? So in order to find the turning points, you're going to use the exponent of the leading term. So basically, you're going to use your highest exponent and you apply n minus 1 to find your turning points. So this right here is a graph of the line y equals x. That's y equals x. Now you'll notice that this graph, if we read it from left to right, it's going up the entire time. Therefore, it has 0 turning points. Now think about this. If I apply this n minus 1, my leading term is this x here. Its exponent is 1. So if I do 1 minus 1, I get 0. So there are 0 turning points in this graph. All right, for this one, now I've already told you that a turning point is where it's going down and then it starts going up. So we already know that this one has 1 turning point. Hopefully you recognize that this is a parabola, which means it's a graph of a y equals x squared. It's actually the parent function of quadratic functions, y equals x squared. So if I apply this n minus 1 to this one, my n here, my highest exponent, is 2. So 2 minus 1 is 1. Now that'll work for these two. It gets a little tricky when we talk about a polynomial of degree 3. That means where we've got something that's y equals x cubed. Okay, that's what I'm talking about. So for one like this, you're basically going to have to graph it, because you could have a graph that looks like this, and in this case, this has 0 turning points. So this one here has no turning points, and usually I just usually write 0 t dot p dot, 0 tp. So there's no turning points. But this one over here is the graph of a cubic function, x cubed. And notice I'm going up and then I start going down. So that's 1 turning point. And I'm going down and then I start going up again. So that's 2 turning points. So this one has 2 turning points. So for cubes, you're going to have to graph them, okay? Now, down here, I have some examples. It says draw a sketch and describe the graph of each function. What that means is I want you to tell me its end behavior and how many turning points it has, okay? If it has any turning points, that's what we're going to look at. So let's go to Desmos and let's graph y equals 1/2 x cubed. All right, let's go to Desmos here. And these were the ones I used earlier, so let's cancel them out. All right, y equals 1/2 x cubed. Y equals 1/2 x cubed. All right, it looks like this. So its end behavior, it goes down on the left and up on the right. So its end behavior is down, up. And I'm going to write that here so you guys will know it when we get back over there. End behavior is down, up. And you can see how I did that on my paper in just a minute. And it has no turning points because it's going up and it kind of levels off a little bit here, but then it keeps going up. It doesn't start going down. So this one has 0 turning points. No turning points. Now, if I wanted to sketch a graph of this, what I mean by that, I'm going to come over here. I'm just going to draw an XY coordinate plane, and I'm just going to do a rough estimate. It looks something like that. Okay? That's what I mean by sketch the graph. Just draw a sketch. Okay? Pause the video and try this one, graph it in Desmos, and see what type of end behavior and turning points this one has, and then draw your graph. Okay, if I go to Desmos and graph this one, we've got y equals 3x minus x cubed. Okay, This one looks completely different, doesn't it? So we're going down, and then we start going up, so that's one turning point. We're going up, and then we start going down again. That's a second turning point. So this one had two turning points, and its end behavior on the left is up, and on the right is down. So this end behavior is up, down. All right, and if I wanted to graph that on here, I would just do a rough sketch to look something like that. Okay? All right, if you have questions, let me know.